Here's another familiar friend. F of x is the cube root of x. We saw this back when we did the first derivative, but this time we're asked about where it's concave up and concave down and inflection points. That is all in second derivative world. So when we did this before, we looked at critical numbers, increasing, decreasing, relative max and min. All that's first derivative, but now we're asked about second derivative things. It's still the same two steps, but with a different derivative. So what tunes me into knowing that it's the second derivative is the concavity and inflection points. Well, before I can even take the first derivative of this, I'm just going to take a second and rewrite it. This is really f of x is x to the 1/3. Power over root. Power is 1 when it's not written. Root is 3 here. Now I could take the derivative, bring down the power, subtract 1 for the new power. If you need to, you can do some side work. 1/3 minus 1 is minus 3/3. So my new power is negative 2/3. I'm not going to do anything with the first derivative because I'm not asked increasing, decreasing, relative extrema, critical numbers, any of that. So I don't need to do anything with the first derivative. I'm going to bring the power down again and take the second derivative. I'm going to do this where I don't multiply it out right away just because I don't have a calculator right here. So I'm going to bring down the power and subtract 1 for the new power again. Negative 2/3 minus 1 is the same thing as minusing 3/3. So negative 2 minus 3 is negative 5/3. There's my second derivative. I want to set that equal to 0. When I'm thinking about solving, I'm thinking, do I have an x squared so that I have to factor? Is it a linear equation like 5x plus 1 where I want to subtract 1 divided by 5? Or is it a fraction where I want to make the top 0 and the bottom 0? Well, let's simplify this a little bit so we can figure out what case we have. I noticed that first of all, I can multiply some things out in the front here. I can multiply the top with the top and the bottom with the bottom. And then also, this negative exponent should go down to the denominator where it belongs. So I'm going to rewrite f double prime by multiplying the top with the top and the bottom with the bottom. So 1 times negative 2 is going to be negative 2. In the bottom, 3 times 3 is 9. And you could use your calculator as well. 1/3 times negative 2/3 is really negative 2/9. And then my exponent is negative, so I'm going to put that in the denominator as well as being positive. I need it to be 5/3 in the denominator. And that's what I'm setting equal to 0. So this is our fraction method. A fraction will give us 0 or undefined if either the top is 0 or the bottom is 0. So can anything make the top 0? No. Negative 2 is not going to ever be 0. In the bottom, 9 times something has to be 0. And you could divide by 9 and try to solve for this, or you can think about it. 9 times something is 0. What's that something? It must be 0. So instead of dividing by 9 and like taking a root to try to get rid of the 5/3, raising it to the 3/5 power would be the algebra way. We're just going to think about it. 9 times something is 0. The something must be 0. So this x is special. This is my possible point of inflection. I want to figure out, is it a point of inflection? It's only an inflection point if concavity also changes there. So I'm going to figure out if it's an inflection point by making a sign chart. My second step. Putting 0 here, it's special. It makes the second derivative what? Well, it makes you divide by 0. So it makes the second derivative undefined. It's only an inflection point if concavity changes, and it also has to be a point on the graph. Like if there's a vertical asymptote there, it doesn't matter if concavity changes. It won't be an inflection point. So let's see. We want to plug in a number before 0. I can choose anything I want to. Maybe I'll just choose negative 1. I'm going to plug into my derivative here. So the top is negative 2, which is going to always be negative. And then in the bottom, I'm going to have 9 times negative 1 to the 5/3. Well, I know 9 is a positive number, so I don't have to worry about that. 9 is positive, but then I need to probably use my calculator on this. Negative 1 to the 5/3, or you might know negative 1 to the 5th is going to stay negative, and then when you take the third root, it's also going to stay negative. So you can use your calculator, or you might remember from algebra. Oops. So I have a negative divided by a negative, really, when you simplify this out, which is going to be positive. If the second derivative is positive, the function is concave up. Careful, we're not going to say increasing. That's in first derivative world. The next part of the sign chart, I can plug in anything I want to. I'm going to plug in 1 to the factored form of the derivative here, so, or really the simplified form, has a -2 on the top, which is negative. In the bottom, I have a 9, so that's a positive number. And then lastly, 1 to the 5/3. 1 to any power is always 1, so it's going to be positive. But again, you could use your calculator and type in 1 to the 5/3 if you weren't sure. A negative divided by a positive is going to be a negative. A negative second derivative means it's concave down. So do I have an inflection point? Yes. It makes the second derivative 0 and it has a change in concavity. The two things I'm looking for. Checked out. So, and it really makes the second derivative undefined in this one, but as long as concavity changes, it is an inflection point. So we need to find the y value of it. So I need to plug into the original. This is the only time I do. The original was the cube root of x. So I'd plug in f of 0, and the cube root of 0 is 0. My inflection point is at the origin. And then for answering concave up and concave down, remember to the left is negative infinity, to the right is positive infinity. So I am concave up before 0. So negative infinity to 0. And then after 0, 0 to infinity. So there is all of my work doing our 2 steps, but with the second derivative.